more refined way to use this queue is to accept the incoming messages. How we'll store 11 here, and if we have a null character also. The session I have chosen, this session all the messages I am delivering, right? If the queue is piled up, so I am making sure C1 is connected, C2 is connected, only one thread is running, which is main thread, because till this point I have the access to the room and it should have the access to the message queue and size. Hey everyone, so let me set the context for this video. So basically we'll make a chat room application from scratch in C++ today, and this video is gonna be a value bomb for you. Why? So we're gonna cover so many interesting stuff, including how to write your own protocol so that our server can understand that, how to use async IO input output, right? How to use complex libraries like boost library of C++, and how to use multi-threading, how to use debuggers, how to debug C++ code effectively, right? And this project you can add in resume after our extension. I will give you homework of extension that this project may be extended little bit more. So yeah, that's it, right? So I'll start the video quickly. So let me reiterate again. So we will be going through each and every step of how to define your own protocol so that your server can understand messages, how multiple clients can join your server, and to be precise, how multiple clients can join your room, right? How we can create session per client, and so that one client can send messages to all other clients present in that room, right? And all of this happening is through async IO, right? So the people who have already done our applied operating system playlist, they would be able to understand this project more in better terms. But people who are just new, it is also fine, right? That I understand that you guys need a kind of scratch basically the understanding the TLDR of some topics, right? So yeah, no worries. So I will be giving that to you. So I will be running through all the threading, event loop, and everything that we are using here. So without any further ado, let's start the video. Okay, I think everyone is able to see my screen. So yeah, so basically before starting the video, I would like to I would like you all guys to comment in the video, right? And like the video, share the video, so that we can reach to more people. And soon we'll upload our new playlist, which is applied DBMS, database management system. And along with that, we're gonna launch something for people who are interested, right? Who are interested in building something or learning on their own or learning with me, right? I'm not gonna launch any course, don't worry. So yeah, so I will going through some of the HLD LLD kind of mixture, right? So that you can get an basic idea what we're gonna do, implement, and all the stuff. So yeah, basically this is our server, right? This is our server. Let me make it large, right? Server, and this is our client, right? So server client model, I hope everyone knows that client is able to request to the server, right? Client is able to make request, and server is able to respond to those requests, right? This is a very basic client server model, right? And just give me a minute. Yeah, and this also, yeah. So client requests, right? It make a request and server gives a response, right? Now this request can be made through any protocol. Now what is a protocol? So basically whenever you are trying to communicate with someone, right, you need language so that you can understand the other person intentions, their whatever they are speaking. So there is something called rules, so that other two-way communication can be done. So those rules combination we call as it is कि this is a protocol, इसको protocol बोलते हैं, right? सो प्रोटोकॉल कुछ नहीं है, एक सेट ऑफ रूल्स है जो हम डिफाइन कर देते हैं. जैसे HTTP इज अ प्रोटोकॉल, So HTTP has bunch of rules, like it should have version, it should have connection alive, it should have some bits, it should have some encryptions in all these bits, right? So different kind of rules. So what we are doing is key, this is a simple client server model. So in our today's video, what we'll do, this is our server, right? So whenever a client joins to a server, right, now I will make a high level diagram for the server, right? So whenever a client joins a server, so our server is basically a chat room, a broadcast room, or Discord channel, right? So what it will do is a client joins, right? A client joins. So whenever a client joins, what we'll do is for that client we'll create a session, right? We'll create a session. So the people who are interesting, you can go to GitHub, right? And you can go to ChatRoom. The detailed one, the detailed LLD I have posted here. After the code implementation, it will look like something like this. Okay, it will look something like this. So it is kind of scary, but don't worry, I'll explain you, and after that, after code, you will get here and you will try to understand. Okay, you have to do it. So yeah, this is a server where people wants to connect, send message and all. Whenever a client request comes, right, a client request comes, right, so we'll create a session for that client, right? Now after creating a session, we will we will have one room. Whenever a server is created, that server should have one room, right? Now this is a chat room, right? So whenever a server is created, we have to make sure that a room exists, and it will exist at the start of the server, even though if the client is not there, if no client is there, right? If no client has connected yet. So yeah, I think it's fine till now. So the next step is basically this room. I've created one session for that client. Now this session will be able to manage some things, right? So what are those things is this session itself will have some stuff in it, including some queue, right? A message queue, right? So here I'll say message queue. Every client will have its own session, and every session of that client will have its own message queue. Now whenever client will send message, right, whenever a client will send message, right, it will come in this queue, it will come in this queue, right? But more refined way to use this queue is to accept the incoming messages. How we are doing that, let me explain you. So whenever a client send message, we are directly pushing that message to our room queue. Now this room queue is a global queue for everyone, right? This is a client one, we have created a session. So whenever client wants to send message to that server, what we will do is we'll directly send that message to this queue. This is a room queue. Now here multiple clients can send messages, right? Now we are talking about only one client. Bear with time, right? I will explain about other clients also. Now these messages are being delivered from clients, right? Let's suppose now another client comes into the picture, right? Another client comes to the picture, and it will have similar thing, which is a session. Every client will have its own session, right? So whenever this client is sending a message, it will push that message to here, right? Here. So two messages will be there in the queue, right? Now each room has a kind of set, right? Each room has a kind of set, which is participant set. So it has all the participants who are participating into our what do you say, this room, right? So participant 1, participant 2. So basically what I will do is every participant has session, right? So in terms of LLD, what I will do, I will create a participant class, okay? And every participant, this class is a generic, so every client is a participant, right? So this is a participant, and every participant class is extended, and I will make a new class which is a session, right? Session class. So that's where this session is coming from, right? This session. So from this class I will implement this session will have message queue, right? This session will have write, read, all those methods. Those are secondary, but the high level view is this. Whenever the client will be passing a message to the server, it will pass that message to the room which this client is a part of, right? This client is a P2. P2 is a participant though, but participant again, session is a subclass of participant. So if I will tell you a session or a participant, it is the same thing, okay, in our further video also. Okay, so now two clients have delivered two messages and I have a participant sets. Now I know that this message came from client 1 or P1, this message came from client 2 or P2. Now this message, all the clients I have to send this message, but not to P1, because see, I am sending a message to WhatsApp group. It should deliver to all the participants excluding me, because I am the one who sent the message, right? So this client 1 or participant 1, it should not get its own message, and this client 2, it should not get its own message. That's why we are maintaining a participant set, so that when I am sending this message, what I will do, I will send a message to client P2. I'll put this message to message queue, right? And this message which is being sent from P2, I will send this message to P1. If there is another client, let's suppose 3 clients, so I will send first client message to client 2 and client 3, right? Because C1 is the one who sent the message, right? I don't have to send that message back to C1, right? Now let's suppose there are 3 clients and C2 sent the message, then that message has to deliver to C1 and C3, right? So let me give you an example. Let's suppose C1, let's take C2. So C2 is the one who sent a message to the server, right? So all the clients which are the part of that room, right? Let's suppose C1 and C3. These all are the part of that same room, right? And that room is handling those messages. Now whenever this C2 will send a message, so it should deliver to, the message should deliver to C1 and C2, C3, right? Okay, whatever, C3, not to C2 back again, right? So that's why we are maintaining a participant set, so that I can keep a track of how many participants have joined my room, participant or session, right? Because these are both classes, like who are extending, basically this is a parent class, this is a subclass, right? So again, this message queue is for the incoming messages. So this client has message queue which is for the incoming messages, and this server has the message queue which has the incoming message to the server, right? So that it can have, let's suppose when some client is taking time, right, other clients might accumulate this queue, they might send too many messages in this queue, right? So when another client is busy in handling the messages, then these messages flow, right? That's why queue based implementation is there, so that we don't lose any message in between, right? So that is the core functionality, right? We have participant set, we have message queue, we have room, we have session, and we have participant. So participant is nothing but I just, to give an idea of object oriented programming, I just made a participant, right? And I've referred someone repo, and basically I took the design idea from there, then I've decoded it according to my needs, and then I've coded that and debugged this, and now we are here, right? So this is kind of overall idea that we'll try to do. So what we'll be using it there is, we'll using threading, we'll be using boost library, async IO, right? And we will be using some Makefile. So the people who are new to our channel, they can refer our C crash course, is just 2 hours long, right? Very basic course, and it will give you a very good TLDR of your or it will give you a good revision of your C concepts, right? So I would highly recommend you to go there and refer that course before, so that you would be able to see how Makefile works, right? Okay, now the another thing is CPP. Oops, although our CPP crash course is also coming for the beginners, but the people who already know CPP, they should be able to do this project or extend this project, right? And the last thing is, I think, memory management, right? And protocol design. So this is a design that we'll be following. LLD is already given to you here, right? That I don't want to explain as of now, because you will be overwhelmed by my explanation otherwise. But anyways, let's get back to the coding part. Okay, so first of all, why I'm designing a message. So basically whenever I am in the server, right, client is sending some raw message, so I will be using sockets, right? So everybody, I think everybody is aware about the sockets, right? Socket is nothing but a kind of API that our operating system provide us, so that we can use use those network, APIs to send or receive any data over the network, right? So these are nothing, you can read more about this, but like one blog you can refer and it's enough, right? The sockets, yeah. So whenever the client is connected with server as a socket, right, that server will be able to handle that client, right? But the thing is ki this server needs to understand this message. So what it will do is client will send the raw message. Let's suppose client wants to send hello world, right? Now this server, if you want to extend our project, you want to generically define this message, right? So for that we will be designing our own very basic protocol, our rule, right? So that we can make a raw message like hello world to a structured message, hello world, right? A structured message, how we are making it is ki we'll make a data, right? We'll make a array where first few bits, first few 4 places will store the length of the body, right? Let's suppose the length of the body is 512 characters, so I will be storing here is 512, okay, whatever. So I will be storing here with 4 digits 512, right? So I'll be encoding the header 0512. I'll put zeros in prefix, so that I am just pretending to encode something secure. It's not secure, but what I'm saying is I will always represent the length as 4-digit length. Let's suppose the data that we are storing, hello world is 1 2 3 4 5 6 7 8 9 10 11. So we'll store 11 here, and if we have a null character also at the end of our character array. So this 11 plus 12, so what I'll do is I'll store 0012. So this is our simple message structure, right, that our server understand. So it has header, it has body, right? Header has the body length, and this body has the data. So this is a kind of protocol that we will be using. So this hello world, raw hello world will come to server, will encode this message, will make this message such a way that our whole server is aware about how to get message length, how to get its body, how to access if it is a valid message or not, so that we can control the messages. We don't have to do everything again and again. What everything I am mentioning is, let's suppose hello world has some special characters, and in future your server don't want to handle the special characters. So when you have a message protocol, there you can write a function of validation, right? This is where OPS, object oriented programming comes, right? So that's why we need to design a message protocol first. I think this much text is fine. So whenever you are making a project, so basically for the guys who are new to CPP, I'm using a UTM, right? I'm using a UTM in Mac. If you have Mac M1, you can use UTM, and you can just search about the videos how to remotely connect to UTM Ubuntu server from VS Code. Any video you can refer, so that you can use because CPP syntax is way too easy to follow in Linux, right? The IntelliSense, the LSP, everything is good. But if you are using Windows, then WSL instead of UTM, replace WSL, right? So I'm hoping like this simple thing, my audience is intelligent enough to figure this out. So include IOStream, basically standard input output, whatever we use in C++. If not define, chat. So the people who are old to our channel, they know that we always do if not define, then define, and then end if, right? Okay, and if, okay, and ChatRoom. Okay, now so you just go here and also check install boost library in Linux. You have to install boost library, so this sudo apt get install libboost, right? After this you will be able to use boost. So I'll also be digging deeper inside how to use debugger and event loop also when you will come to async IO, right? So as of now you can consider this thing, include boost asio.hpp. Yeah, it's working fine, right? But in message we just have to define the structure of the message like our protocol, so this is not needed. Okay, this is our message. So I was just explaining you how you can use boost library. Anyways we have to use this. Okay, whatever. So we have to define message class. So there is a limit that we want to put, right, on the this thing on the header that we have just explained you. So for that we'll put header length maximum to 4 and maximum bytes that it can have. So basically I'm considering one array, one character is equal to 1 byte. That's why the body length also I will put a limit. So before that let's use initializer list. So I want to make body length such that anyone who is using my message protocol wala message, he should be able to access my body length without any my functions should be able to access this body length. So what I'm doing is I'm making this body length and one data. So data is nothing but this one only, this thing, right? So data header I have not defined yet. Max bytes, size t, you can read more about size t. So basically whenever we are using to represent data length and everything which is not which can't be negative, so kind of there we use size t, body length underscore, right? So now this header and max bytes I have to max bytes. Max bytes 512, body length no header 4, right? Max bytes I have to make sure that the maximum bytes I can incorporate in my data is 512 and the header length should be 4. So whatever the bytes I'm gonna store in my data should be equal to 512, the max bytes, and the header should be represented using 4 bytes. So that's what I've just wrote. Standard string and message. Okay, so body length is equals to get new body length. So basically what I'm doing is I am making a basically typecaster. Basically whenever I will have a message, a raw message, I want to convert that raw message to my message, right? So I'll accept one string. I should include string. And okay, so I have to make sure that if that body length, whatever I have the body length, so there is one validation. So first validation is get new body length. Okay, get no, message get new body length message dot string has length new length, right? I think this is fine, right? Message dot length, or maybe I can use message dot size also. Let me go to inside message, number of characters in the string. Okay, fine, size also works. Size t. Okay, if so I have just to make sure that if new length is more than max bytes, so return max bytes means even if client sends me a large message, I'll only be able to incorporate these much bytes, which is 5112. Otherwise you can, if the length is fine, you can just return that length and that's it, right? Okay, so first of all we have the first validation we have is the whatever the length is in code header. Now the second one is in code header. So basically I have just explained you that we'll be encoding header to always 4 digits, right? So what I will do is this is void. Why? Because I will encode header, I will use this message, I will encode the header and I will store that header in my data itself, right? I don't have to return. So encode header. Okay, 27 minutes already gone. Encode headers, char new header. So basically I am just making a placeholder, right? So header could be header maximum one, like maximum 4 bytes, 4 characters plus 1, because the null termination is also there. So I'll create a new character array, and what I'll do is I'll use printf function. If people don't know, let's go inside. So printf, this is a possible write format, printf. Okay, so I don't think the explanation is there, but yeah. So printf we are using just to copy some stuff. So basically new header, into new header we want to copy, so we want a formatter. So basically for that we use printf. So basically as printf basically, right? So string print with format, whatever you can say. So then we call static cast. So basically what we want to do is we have this basically body length, right, which is in size t. So basically we are just converting it, and I think you can make sure you can like run it without conversion also. Just this is just a check. Then we are just blindly copying this, right? So whatever we have new header we have formed using this prefix 4 digits. So if there are no 4 digits, embed the zeros into the prefix. If there are 2 digits, embed 2 zeros in the front so that we can make 4 digits. That's what this printf is doing. And mem copy, for mem copy I think we have to include something. Memory mem copy into data, we want to copy the new header, and how much so how much length we want to so basically new header, we have formed a new header, so from that we want to copy these much characters. So mem copy. So for mem copy, what is the include mem copy, from where mem copy comes? Let me check. String.h, really? Okay, fine, it's coming from string.h or c string, or you can include string.h also, whatsoever you want to do. So yeah, that's how we are making a message, right? We are encoding a header, and after encode a header, we have make sure that this data and header I have made. Then only thing I have to store is only thing I have to store is the data which is coming from this message. So basically I have formed this header which is 4 digits, right, from the body length, right, that we have just set up here. Then we have to make sure that the data is present. So I will start data plus header. So basically we are skipping first few bytes, plus we are directly, so basically header is already stored into the first 4 places. We are skipping those places, 4 places, and directly storing the data starting from the next place. So basically we are making sure that our pointer comes here, right? So from here, message dot cstr, so what it will do is string return constant pointer to null terminal, whatever. What it do is it will give you a character pointer to the character array. So basically I have the string, I have to make sure that it converts to the character pointer, because that's how this mem copy is designed. And I have to make sure that this this copy lasts till the body length, whatever the body length we have calculated here. So we have body length, we have used that body length. So it will, so if there is any extra space, what it will do is it will just null terminate that body, and it will just copy till this body length, and other 512 bytes, whatever the maximum bytes we will have, maximum places I should say, those will be empty only. So that's how we are constructing our message. So to further optimize it, I have just an idea to further optimize it, you can make it dynamic also, right? Something called vectors, but it's up to you, right? So then we have some getter, setter, all those kind of stuff. So get data, I will directly code this header. We have 4 bytes of header, then we have body length, right? So basically what we are doing here is okay, so yeah, we are just making sure that this result is returned. We are making a string, then what we will do is this is the whole data that we'll get, then we'll define. So these are just the extra functions that you want to give inside your message protocol, so that whoever is using the message, your constructed message, they have the some top of the methods that they can use out of the box, right? Okay, result is equal to videos on, right? Okay, okay, so data string dot substring. So if I only have to return the data, then from the header till body length I will return result, right? So this is just to get whole data, and this is just to get the body. That is it, I think that is it. So whenever we are encoding header, our encode header, so whenever our client is sending message to our server, we are encoding the message into our protocol. So whenever we are sending message, it's fine, right? It's fine, my server is able to understand this message. But whenever we are writing this message back to our client queue, we have to make sure that we are sending the raw data back. So we should have something called decode kind of header, right? So decode header we'll use. So advanced encoding also you can use, right? We didn't use that, but advanced encoding also you can use that. Again, header, we want to make a character array header plus null character termination, that's why +1. And this thing is fine. String copy, in new header we want to make we want to copy header from data, right? You can read more about these functions in this. If you don't find any explanation, go here, type man, right? You will be getting some documentation here, all the arguments, if it accepts character array, if it accepts pointer and everything. If you still don't find anything, then go to internet, obviously, right? If you still don't find on internet, ask LLM. New header, so we are null terminating it by ourselves, right? I think new header, yeah, header is 4, so 0 1 2 3, fourth character is null character. Yeah, fine. Okay, header value a to integer, character to integer. Okay, new header. Yeah, so what I've done is ki I've made sure that this header, I've copied the header, right, into my new header. Then I'm using that new header to convert it back to integer. So basically this 0 0 1 12 whatever we stored in character array, we're making sure that this 0 0 1 12 will be converted to integer, which is 12 only, right? So basically encoding is putting zeros. If it is not of the number doesn't have 4 places, then we'll put the rest of the places with 0 prefix. If the number is huge like this, we'll not put any 0, right? If it has 1 0, then we'll make sure the decoding is 1 1 2. It's very simple decoding, right, to just give you an idea of how to make a protocol, very basic protocol. If header value is more than max bytes, so basically which means somewhere we have messed up while constructing this whole thing. We have stored the body length more than the allowed length in this body, right, which is why we are checking this. Then we can do we can do nothing, right? We don't want to write that body to back to our sockets, because see, in that case faulty data might go, some garbage data can go, not garbage collection. So in that case we'll send key by we are not able to decode your header because something is going wrong. Otherwise what we'll do is we will set the body length to header value, because this header value now is decoded to integer, which has basically the numbers which represent nothing but your body length, and then we will return true कि भाई सब कुछ सही चल रहा है, don't worry, we have converted everything back to your whatever you wanted, right? Okay, अभी फटाफट chatroom.hpp लिखते हैं, हेडर फाइल लिखते हैं chatroom की, ठीक है, so that ये तो हमेशा कर लिया करो, ठीक है। if not define chatroom hpp, जो हमने मैसेज अभी अभी बनाया है वो हम इंक्लूड करेंगे, message.hpp include. So set, why? Because participation set we have to make. Then memory, because of some other packages we have to include sockets. And we have to include some more libraries. How do I know? Because whenever I wanted to use some functionality, I just searched which library does provide this functionality and which function, Oh, IO stream is already. So boost library, ASIO package you have to include. That's all. So now we want to use a namespace called boost ASIO IP TCP. Now what does namespace is? I'll just go here. So this is a class TCP, right? So what happens is, let's suppose I have class TCP in my boost library in one package which is tcp.hpp. Now let's suppose I have one more class which is again TCP but not in IP. So basically what happens is, you have a boost package, into that you have ASIO folder, into that you have IP folder, some base file of IP, and into that you have TCP, right? So what happens is, let's suppose I didn't define any TCP, right? Or let's say I didn't define any namespace, right? What will happen is, let's suppose in this boost library I have one class called TCP and I have another class called TCP again in another file. So how to distinguish that? So how we are distinguishing it is this TCP class is included into IP namespace. So namespace is nothing but an identifier which distinguishes different classes which might cause same name issues. So that's why this namespace I'm using, this namespace itself is nested in ASIO, and this is in itself is in Boost, right? So that's how these namespaces are defined. So that's why whenever someone use namespace, they can define their own namespace. Let's suppose I want to define namespace class ChatRoom. So the general code, whatever we used to write, will just go here. That's it. So someone, if you will try, will say कि भाई use this chat namespace first, and then you will be able to use this class. If we are not using any namespace, someone can directly use that class. Okay, so that is the power of namespace, and using this make sure that wherever you will import any TCP functionality will solely comes from this TCP. No more classes of named same will be used, right? So yeah, participant. So first one, we have to make sure a participant. So participant is nothing but an interface, right? So in C we can use virtual functions. Virtual function, I think, about which can be defined without any definition, right? So okay, so this is a pure virtual function which is की equal to 0 भी आपने कर दिया. Virtual function. So a participant will have three main method, which is deliver, which can deliver. So participant is nothing but a session. Why? Because the main class is session, which will extend this class, right? So message equals to 0, and one destructor. This is nothing but default one. So now okay, so this participant, so basically whenever we are using a participant, so what we'll do is key, whenever a client is created, it will have its own session, right? Session is nothing but a participant itself, and this session will be a shared pointer. So you can read more about it, but the shared pointer is something called a good pointer to use whenever you want to define a pointer's ownership. So let's suppose in C, if you have done a C crash course, you would know that if I have made any pointer and that pointer is owned by multiple people, then multiple people can free that pointer, because everyone is pointing to the same pointer. So if one person is freeing that pointer up, then the second person will not have any access. So these kind of stuff can happen. But with a shared pointer, you can only own, our ownership is defined. So if I am owning a pointer and some other people, some other person wants to own it, I have to move my ownership to that person. I've explained that before also, but you can read more about it. But we'll use shared pointer. So that's why whenever you are using shared pointer, it comes from standard whatever. So the simple pointer, you will just make participant. That's it, participant star. Okay, whatever it came, but participant star you'll use. But for shared pointer, you have to make sure that you wrap this up in this, right? Participant. So wherever I will use participant pointer, so wherever I will type this, it will indirectly replaced by this line. So that's what type define or type def is used for, right? Now you will create a room. Okay, now before room, we have to create a class session, which will nothing but it will extend a participant class. So a session is nothing but a participant, so you can say a session will always have participant, right? Okay, and one thing which it will use is enable shared from this. What exactly this is, I will tell you. So whenever a session is created, right, so we are using that session, we are doing some stuff, but whenever we want to move this session to room, so basically every session joins a room, every instance of client instance is session joins a room, right? Because see, every session joins a room means कि I have to make sure that this session is owned by room, right? So that's why I have to use something called enable shared from this. So basically whenever I want to share my object or a pointer to this object, I can share that pointer as a safe way. So to share that, you have to make sure that public is written here. So I've debugged it for 30 minutes and I was missing public. Something caused like weak pointer exception. But yeah, if you will use public and enable shared from this is key, then whenever a object of this class is created, you can pass that object as a pointer to someone and move the ownership of the object to not any of this class but to someone else. Yeah, so some stuff is there. So I'll create now this socket. I'm not using any C++ or C language inbuilt sockets. I'm using the boost IO sockets, right? So this default constructor will accept these things, these two things, right? So basically we are making a HTTP file. It will have nothing but only the signature, method signature, right? So it has start, it says deliver method. Every session can deliver a message to a room, right? Every session can write a message to room, not to room. Basically every session can write a message back to the client whose session it belongs to, right? Async read. What this async funda is, I will explain you. Okay, private. So basically we have to have one socket. So basically every session will have one participant. I mean every session will have some client, right? So that's why we will store some sockets so that our methods can access those sockets directly. They don't have to get the socket from the parameters again and again. And another thing is stream buff. So this is a buffer. So whenever it is reading or writing, a buffer is needed. Basically whenever you are reading from sockets or writing to socket, a buffer kind of queue is needed where you put characters and those characters are put back to the socket, because socket is network based. It can take time. So when the time is there, the latency is there. So meanwhile those sockets will not accepting any new characters to write to. Then what they will do is they will use buffer only. So buffer is a kind of buffer right, a placeholder where the characters can go when the socket is not responding for some time, the latency is high, right? Okay, this and then double-ended queue message. You can make it as a queue only because I'll use it as a queue only. DQ message, and for DQ I have to include DQ. Okay, fine, I think, right? DQ, everything is done. Now coming back to the room. Now every room will have a join method which will accept a participant pointer. Participant, let's just make this as okay. So every join method will get some session pointer or participation pointer. And every participant can leave participant pointer. Okay, and every room will have a deliver function where a participant comes, right? Deliver method is one where participant will come and then it will deliver a message. It is very important, right? Just pay attention. It will deliver some message and we are passing every message as a reference because it doesn't matter, right? Message, we are not doing any write or something like that. We are just reading body and all, and each message is handled by only one method. So you can do that. Even it has queue message. I've explained you, right? Every session and it both has queue, this one and this one. Okay, message queue. Max participant also we can define. 100 point participant, and set of, I've already explained you that we have to make sure a set of participant is existent, because when you will send message back to clients, you don't want to send that message to the client who has sent that message already, right? So that is the reason. So participant pointer, and we will make a, so yeah, this is our old chat room method signatures. So now let's get back to code. Okay, you'll get the code well commented with LLD, everything in detail in comments, okay, in GitHub repo. Don't worry, after this you can just refer that repo. Okay, so first of all, whenever someone joins a room, right, what we want to do is, it will have participant pointer and it will have participant. What it is doing, okay, IO stream is already included here. I don't have to include again. I just have to include one thing, it is chatroom.hp. I think that should be fine. Yeah, so we just have to do participants dot insert function in the set, and we have to make sure that this participant is pushed back to the room. So whenever someone leaves the room, right, we just have to flush that pointer up. Okay, till this point everything is good. I think everything is understandable, right? So that should be fine. Void room deliver. Now whenever any participant is, you know, trying to deliver a message, what is it saying? Participant pointer, participant comes here to deliver a message. I think this is the signature. Yeah, so whenever a participant is delivering a message, right, whenever a participant is delivering a message, right, it is a participant obviously, so it will deliver a message like this, but it will deliver a message to the queue, because there could be a case that if it delivers a message directly to all the clients, it is possible that already the queue is full, right? If there is no queue, the server might be busy to handle already, you know, the clients who have sent the messages already. So that is the, you know, main thing. So this is a double-ended queue, that's why push back and push front is there, but you can use only a simple queue also. I don't know why I've used double-ended queue. Now when we have pushed that message, that client message to this queue, now this deliver method will try to deliver all the messages which are into the queue, right? And we have to make sure that we will not deliver that message again to the client who has sent that message already, right? So that is the main thing that we have to make sure. So until the queue is not empty, we want to make a message queue dot front message queue dot pop. So basically what we are doing is, we are doing nothing but we are just fetching that element first message, and then after fetching we are storing it, and now we have stored it, so the queue is consumed, that message is consumed, so we have to remove that message from the queue, nothing more than that, right? So that's how what you will do now is, participant pointer, you will go to the participant the participant set, and you have to make sure that this message that you are trying to send just now should not go to the client who has sent this message already in the past, right? So if the participant, if I'm trying a participant I think गलत मैंने choose कर लिया word काफ़ी, you know, it's hard to type sometimes. Okay, so the participant who is trying to deliver a message, it should not be the participant who we are trying to write a message to. So when it is not, then only we'll write, right? So the one of the reason of defining these methods already is कि you will not get the exception. So because compiler knows that this method exists, right? So that's why it's not giving up any error, because it knows this method is already there in the chatroom.write. So that's why it's not giving error, although we have not implemented any body of that method yet, right? Okay, so write we have to I think we have to, for participant write I have to use async write, right? Cool. Okay, so void session write, it will get message, right? And message queue dot pushback message. So what we are doing is whenever that server is trying to write a message, it is, first of all, it is making a validation, which is I'm not sending a message back to the participant who is trying to deliver. I mean, it's not like I said hello in my WhatsApp group and I got hello back instantly, right? So I will deliver a client message directly. No, I'll put them in a message queue, then that message will be decoded and sent, the raw data will be sent, right? So I'm putting that in message queue first, and then I'm making sure that whatever the session I have chosen, this session all the messages I'm delivering, right? If the queue is piled up, so I'm making sure that I am able to deliver all the messages. Message queue. Okay, so first of all I'm taking my message out, which is message queue dot front. Okay, then message queue dot pop front. Okay, and then I'm trying to check if the message I'm trying back to I'm trying to write back to the client, if that is a valid header, a valid message. Is it does it contain the valid message body? Is it a short message enough according to my requirements that I will define the maximum bytes, which is I think 512, the 512 characters. So if those characters are there, only then I will send that message. So that's why we made decode header, which will send you true or false depending on the the message validation. If it is true, there is no going back. You can just use our method get body, and you can call async write. Now this async write, what is this async write? What does it do? All the event loops thing I'll come back, but let me write the code. As of now, you can just treat async write as a write function and async read as a read function. So what they will do is async write, whenever I'm trying to write back to the client, I'll basically write to the socket of that client, right? So to write that, I'm using async write, right? So whenever I'm reading to that socket into the server, I'm using async read. As of now, just treat async as a read write only. Forget about async. We'll come to that part really soon, right? Message.get body length. I have not defined this method. I think that's a getter only, right? The people who are aware about Java, they know like how to use getters, I think, right? Okay, else you just have to make sure that you are telling the person that message length exceed the max length allowed, right? So this is your write function, I think. Okay, so let's write other functions also of session, right? So that another function is deliver. So whenever a session is created for a client and it wants to deliver a message, right? Okay, so it will just do room.deliver. So room is for every session we have room, right? So basically a session only exists because there is a room available for that session. That's why I have already one-to-one mapped one session with one room, right? So room.deliver share from this. What does it mean is key, if you will go to deliver wants okay, share to this and message. So whenever you want to deliver a message to a room, so you have to join that room, right? You have to present in that room, so that my session is, my session only belongs to that room at the moment. It doesn't belong to anyone else. So that's why I'm using shared pointer. I'm passing my ownership. So basically whenever I'm into the deliver method, this participant pointer or a session pointer is owned by this deliver or room. So that's why I'm using this shared from this. How this is coming is because I have created this, right? We'll come to that, how I am creating this pointer itself. But as of now, you can just treat the deliver method is nothing but it gives the ownership of session to room and it delivers a message. And we have already explained the deliver method here, right? Okay. uh, Now whenever the session is starting, we have to make sure the session start function is also there. So after accepting a client connection, we have to start a session. So we have to create this thing and then async read. So what is happening is whenever we will accept a connection, right, whenever we will accept a connection from the client, we'll try to join a room, right? Then after joining a room, we'll try to read whatever the client is trying to send to that session or to that server. Session is in the server actually, right? So yeah, that is there. So let's go to this thing, accepting a connection from client. That is most important actually. So one boost package will use from ASIO only, IP address v4. What does it do? We'll come to that point later on. So accept connection, one method I'm making. What it will do, it need some things which is IO context, right? What is IO context? Don't worry, I'll explain you. That's why I'm making this video. Otherwise you can refer this kind of project from anywhere, right? Let me complete this, then I will come to the point why we are doing this, why we are accepting the connection and accepting something called IO context, right? So whenever I have IO context, assume I have a IO context, right? I'll create the socket from this. You can go inside the socket, right? So socket option to disabling and implements the TCP node socket option boost IO. So my context. So my context is IO context. What does IO context mean? I'll explain that. Don't worry. But let me check any other app. Okay, whatever. So I'll get a acceptor async accept. So now here I will go give a lambda. So lambda is nothing but a function that you can define inline, right? And this and is nothing but you are passing all these things collectively in this function. So basically it's nothing but a kind of defining a function of name xyz and passing all these parameters whatever accept connection has here and then defining a function. So instead of doing all this, I can do define a lambda function. Apart from this function, after the running this function, it will give two things, which is either it will throw error code, or after accepting the connection it will basically it will have socket also. This thing, I think this yeah. So if error code is not 1, so basically if the error code is 0 basically, So it means I'm able to accept a connection from client, and when I'm able to accept a connection, I have to make a session first of all for that client, right? For that I have to make sure I'll make a shared pointer so that that session can be shared, the ownership of that session can be shared later on. Make shared is the inbuilt function, the generic template. So I'll move, so here you have to move the socket and room. What does it mean is, let's say, okay, so whenever you want to make a session, it accept two things, socket and room. But I want this socket is nothing but basic stream socket. If you'll go here, basic socket protocol, basic socket base shutdown socket. Okay, I was trying to find key how this socket is a pointer, but anyways, this socket is a, if you'll go to move, so it accepts as address, so it will move the ownership of that, whatever you want to move the thing, it will move that, and now this session will own this socket. So that's what I'm using here, and making a session as a shared pointer. So now after making an instance of that point session, I'll start. So in start we already explained that after we have made session, in start we'll join a room. Now whenever we are joining a room, we also want to share this session ownership with the room, so that's why we are using shared from this. It is possible because we have made a session shared pointer itself. Okay, whatever, if it works, I have to make sure that I'm accepting connection again and again and again and again, kind of while loop. So that's why I have to do this. Okay, cool. This and fine. Int main, so let's write our main function, int arg c character argv. So these are just the argument that comes from terminal. So in terminal I'll do like this, chat app, which is my executable, and I'll give my port. So first argument in character argv will be this, and second one will be this. So I need second one actually, so the index is 1. If a user gives less than 2 arguments, what I will do, I'll throw error. I'll define key how you should use it, whatever your server thing is, you can do here. Else what you will do, so whenever this class starts, you create a room, right? One room is enough because you are creating a broadcast server, so every server has one room, multiple session. So every session many to one mapping is there, so multiple session can join one room or multiple participant. That's why we have set of participant and all those kind of things, right? But yeah, boost asio io context io TCP endpoint. How does I know like about all these functions and all? I just have spent like 2 weeks in this library boost io, right? And how does it work, and I've seen a couple of examples of different people, I've learned from them, and then I have come to know that how to use this. So this argv is nothing but our port that will give, and we are making it an integer, and this endpoint accept 2 things. So if you'll go endpoint key definition, we don't have endpoint, basic endpoint. Okay, basic endpoint, it has one constructor and it has address, right? So we have to give address and port, got it. And TCP, then we have to make sure the acceptor is there. Acceptor needs only few things, basically io. Now io context is the better name, argv is the port, right? Acceptor, no. Your context acceptor, what does it accept? Context it accepts, then it accepts one constraint is convertible and value and type. Okay, so basically acceptor TCP endpoint, TCP v4 arg. I have made one endpoint, right? I can give that endpoint here. I don't have to make that again, right? Now I'll call accept connection function here. IO context. So that function that we have just written, acceptor, room that we have just created, endpoint. This room is created using its default constructor, like no args constructor, no argument constructor, right? IO context dot run. Let's see what this method is. If it, like, I know what this what does this method do, but anyway, scheduler, yeah. Okay, now I'll explain you what this async behavior is. So there is something called event loop, right? And this is a stack, this is event loop. So the JavaScript people knows. So we have done one thing, which is we have made one accept connection. So basically accept connection is a async accepting connection. Why does it so? Is key because we see we have IO context. So IO context is nothing but this scheduler, right? This is a our queue, our event loop queue. So this is our IO context and dot run. So basically what does it do is it manages all the life cycle of all the async functions. So our first async function that we have done is async accept. So we'll register this async accept function here with callback. What callback is, we give a function. See, this async accept is has a function with reference, right? This lambda function. So this lambda function will be called when this async function will run, right? So this is called non-IO blocking nature. What will happen is ki our sync code, the sync code is like when you write print hello world, right? Then you call function 1, then you call function 2, then you call async function. So what will happen is first you will print hello world, first you will print hello world, it will go to stack here, right? Then it will run, hello world will be printed on your terminal. Then function, this function will run, this function will run, then this function will run. But now you have, let's suppose, func2. So now this, after running all this function in our call stack, now when your this function is coming and then this function is coming, what will happen is key, it will not run this function, it will not run this function first, it will put that function here, right? It will put that function here, and this function should have some callback, so that when this function will run, this callback or this wake up code can be run, right? This callback has all the parameters by reference, by address. It knows the address of all the parameters in memory. So whenever it will run, it will have all the parameters in its scope and it can run everything smoothly. So when this function will exit, after that this call stack is empty. Now this IO context.run is constantly fetching all the async stuff from the loop. Now the first async accept is this. So this will run, you will accept the connection. Now let's suppose after accepting the connection, you have async read from client connection, from client socket, you have async read. That function will go after this. Because call stack is empty, all the sync code is run, whatever the sync code we have written, like decode header, encode header, whatever. After that, we are running the callbacks that are registered in the async function, and these callbacks have something in reference. So all the arguments they have in reference, so they can run those arguments anytime. So that's the crisp of IO context, these async stuff, right? So we have written right, we have async read, we haven't written async read, and we haven't written async write. I think those two functions only left, if I'm not wrong. Let's somewhere define our async read. So after accepting the connection, whenever the client is connecting to server, the IO context.run will see now accept connection will wake up, and then all the parameters it will have, then it will start the session for that room. All of that will run async, not in sync or real time, but in after some wait, right? Now let's write some so shared from this, whatever I have shared, whatever other session I am having, I am storing that to self, so that I can pass that shared session to my callback, because now I am doing async read. So I have accepted the connection from client, but I will not read until client type something, because on client side, when I will write client, the client will be waiting for user to input the message. Till that point, this function is registered into the memory or into the IO context. This function will not run until it didn't get any message, right? Because it's async. So that's why I have to make sure the session is passed to this async read. So whenever it wants to use some session stuff, it has the access, right? So I have to pass that by reference also, async read until. So we have one function from boost library, client socket. Per session we have already client socket, right here. Every session has one client socket. So from that socket I will try to read, and I'll try to read in the buffer. We have used stream buff, right? If you go inside here, you will see that it accept one async read stream, which is socket, and then it accept dynamic buffer. It will go, if you'll go more deeper, you'll find that is this async dynamic buffer is nothing but a stream buffer, right? That we have already defined. Okay, buffer, and we want to read until enter comes. Basically enter is this new line, whatever, right? Cool. And then this reference and self. I think this is it. Okay, so apart from this, it will have system error code EC, and it will have size. So whenever I'll accept the connection, it will show if it is throwing any error, or if it is what does it do? Okay. If there is no error code, string data boost SIO. So I've just seen this on internet, how we use buffers, right? So it is just that we use buffers, data begin, data end, like kind of vectors only, and so wherever the data from the buffer is starting, plus whatever the bytes are transferred from the client. So it will make sure that buffers.data or buffer.data, I think buffer.data, yeah. So it is storing everything in string data. So now we'll do, after making this data with with this kind of characters, we have to make sure that we are able to store the data. So we'll consume bytes bytes transferred. So using this, now whenever I'm calling consume method, So in consume, I have given how many bytes I want to consume. So what it will do is key remove characters from the initial sequence, remove n character from the input stream, and buffer consume the consume basic stream buff. Okay, stream buff consume, it has the buffer consumption only, and the buffer is this. And I have to, after consumption, I have to store the, though I can call received. So whenever I'll receive the data from my client, I want to print, and when I'll get the data, I want to construct a message from the data. Now whenever I'm reading from the client, I'm reading a raw message, then I'm converting that raw message to my protocol that I have defined, a very basic protocol, right? That only will use, and deliver message, then we'll want to deliver, and in deliver what we'll call, you know, we call nothing, we just join the room and start, kind of, right? We just deliver, and in deliver it's just that deliver, right? So after deliver method, we'll keep reading because the client is still running, it can send more stuff. अदरवाइज क्या करेंगे, अगर हम और रीड नहीं कर पाते, उसने कंट्रोल सी दबा दिया तो कुछ एरर कोड आएगा, कंट्रोल सी से क्लाइंट कनेक्ट मतलब वो हो जाएगा, क्या बोलते हैं, डिसकनेक्ट हो जाएगा। सो मैं क्या करूँगा, मैं उसका लीव मेथड कॉल करूँगा। अब लीव मेथड को क्या होता है, लीव मेथड नीड्स पार्टिसिपेंट पॉइंटर, राइट? सो पार्टिसिपेंट पॉइंटर विल बी making sure that it is erasing its participant, and if the error code is end of file. So basically whenever you click control C, the error that will be thrown is end of file. So then you can type connection closed by peer, yes, and L. If it is not, then the only reason is key you are not able to read the stuff, read error. Okay, so async read is done, async write. So async write we need whenever so whenever we are writing a message, a protocol message from our session to our client, whoever the client has session, we want to make sure the server is sending the message. So this async write is nothing but is called in the write method of whenever someone is trying to write in our room, right? So string, it will have message body, it will have message length. Okay, write handler. Now this is again a lambda kind of thing. Now we are declaring it in different manner. So whenever we are basically writing, so we want to make sure that we make a handler, right? Data is returned to the socket, else we throw an error, write I'll explain you, don't worry. Okay, So what I'm doing is I'm using inbuilt function async write of boost, and it has socket stream, it has buffer, and it has write token. Token is nothing but see, it's a kind of write handler. So token is a kind of function, right? The Java people, they know the function interface stuff. So we will go more deeper here. Sorry, here write token, and write token is nothing but error code and size t function. See, void function, right? So this is what we have defined, a function signature that is nothing but a write handler. So it has error code and a byte transfer, and this handle will be token. So basically inside this async write boost io, this write handle will be called whenever everything is done. It will try to handle the write, like read, right? Read, where is read? Yeah, here. So whenever we're reading, so async till read until whatever, and here, right? So we are using some of the past stuff here, right? This self, where are we using self? Okay, fine. So I think we have everything set up, right? We just have to make sure we write a client. What is it saying? Return 0. This, oh, okay, catch exception is we haven't written catch code. Okay, so I think this is fine. Yeah, now every code error is removed, and this is just fine. Okay, so now we have to write a client, right? Client.cpp. So client cpp is kind of interesting, right? So we have to include message.hpp, we have to include iostream, we have to include boost asio.h. using boost, I'll code it really fast, because I have already coded this and there is nothing to explain, but I'll explain, don't worry. Auto buffer, so async read. So whenever someone is sending message back to my client, I have to read that. Into a buffer, right? Socket I have to read from the socket, and I am using a buffer defined by boost only, and I want to read until end of the file, and then it accept one lambda function also, which we want to give a socket also. It's not picking up socket anyways. So basically I'm not doing nothing but giving here a read handler, right? Instead of making that explicitly, I'm just making that here. So this is called argument captor. So basically in lambda, if we want to use something from outside, we have to make sure to pass like this, right? And whenever it is running, it will either throw error code, which will come directly from boost whenever it is using that handler, whichever way I am writing, and size t length, right? Length. Now if there is no error code, then what I'll do is I'll make a stream. So then again, don't bother about the streams and all this, you can just check from internet, because see, this syntax you don't have to remember, it's hard to remember, I know, but you just have to remember like get line, how you know use get line. So get line is received is nothing but input stream. So whatever the server is sending, we'll print like this, and we want to make sure we are reading infinitely, right? Okay, now so whenever we are coding a client, we have to make sure our resolver is there to resolve an address and port, right? So that's why I have made connect socket resolver dot resolve so second argument is port anyways, that will give. So yeah, so I want to read from that socket. If anything is coming from that socket, read that. And now I'm creating a thread. Why I'm creating a thread, I will tell you, don't worry, right? I will tell you why I'm creating a thread, just to print something, right? In a crash course of C, I have explained why we are using get line instead of C in or something like that, right? So whenever I'm entering a message, I'm reading it in this message, then what I'm doing is I'm posting this context, right? Okay, is there any error? Okay, no. So boost IO post method. Right, so what it is doing is exactly key boost IO write socket whatever. So whenever I'm writing a data, right, whenever I'm writing data to the socket, that is basically writing data to server, which will be given to session, then to room, then to deliver to the all other clients which are connected to that room, right? So that's where this client is basically sending that data, but this all happening is in thread, right? So whenever it is getting data, async read, so async read is happening here, right? So whenever I'm using async read, this is running in the main thread, this is running in the different thread. So I am writing the data in different thread, and the data which is coming from the server is printed from the different thread. So 2 threads are basically running. Why? I'll remove a thread and I'll try to explain you why this is the case. But before that, let's make a Makefile. So I'll not explain, it's just like written everything here, right? What I am doing here is I'm using G++, C++ library, right? What it will do, it will pick chatroom.cpp, client.cpp as 2 source files. It will try to convert all the source server source files to like all the cpp files to O. So this is the this is the target, and this is the prerequisite. So all the prerequisite will come from here, right? C flags O, and this Makefile you can just put in ChatGPT and check what it is, right? And the people who are new to our channel, they can follow our crash course of C, and CPP crash course is also coming very soon. Yeah, whatever. So in VS Code, I don't think you have to set up a launch JSON file, not sure. But if you want to set a debugger, that also I'll tell you today only. Launch. So launch.json file you will always need if you want to debug your code, right? So what this launch this function is, key, you will just go here and gdb attach, right? So something like this will come, right? But I don't want to use this. I want to use launch gdb. So launch file will come, and this cwd will be anything is same, like everything is same, sorry. And which is your main file from. So whenever you'll run Makefile, it will compile all the things and will generate 2 main executable. One is chat app, which is our server. One is client app, which is our client, right? So the main this debugger we want to connect to is workspace folder, whatever our folder is, which is our this folder, the outer one, root folder, and there we'll have chat app. So this is the launch JSON file that it will explain. Everything is in the description, GitHub repo. Don't worry, सब कुछ है वहाँ पे. You can refer, no worries. So basically I've basically commented, ठीक है, पूरा comment मैंने कर दिया है, right? Everything is commented here, right? And everything is sorted out. Even the readme is there, whatever we are doing, right? Fine. So let me show you the process of making a file first. So I'll use this thing. Let me close everything, I think. Okay, so I think every terminal is visible. Let me, okay, now I think everything is visible. Fine. Okay, so you can run make clean command, which can basically remove all my generative files. There is no generative file actually. Then you can run make command, right? So let me show you the working first. So I'll run the make command, right? Then I'll have 2 main apps, which is chat app and the client app. Where is client app? Client app, right? So I'll run chat app on port. How I'm running it is key. Let me show you. So a chat app executable space 9099 is the port. Enter. Now this service is running fine. Now there is no client connection. Client app, first client is trying to connect 9099. Now it's connected. Now this is the thread. This is the different thread where we are always asking input. You can put debugger points also. How to put that I'll tell you, don't worry. So everything is like enter a message, everything, this shit is going here in the different thread. So this is the different thread, not the main thread. So hello, this hello received in the server, but that hello is not coming back to this client which has sent the hello message, right? Now let's connect another client app. Now this is the C2 client. Now if I will send hello, it will get hello. Now C1 is sending message, and same room has this client, so C1 message is able to deliver to C2. Now let's go client app 9099. Hey guys, what's the plan on weekend? So C1 got the message, C2 got the message, but this client is not there. So I'll close the connection. Connection closed by peer, right? let's remove this client. Now these two clients are there. Now let's go, right? Hey, received, hey, received this message. So every client is able to send a message to the server is printing that, and all other clients are getting those messages back, right? And the client who is sending the message is not getting the message back. So that is where this stuff is going on. Why I have used the extra thread here? Because async read, wherever I'm reading. So let's suppose, hey man, what you are doing? Now this client is sending C2, this is a C2, it is sending a message. So C1 will get a message from server, so it has to async read, right? And in the same time it's basically writing to the server, right? So if it is constantly waiting for the write, how it will read whatever it is coming to the socket? So that's why I have to use two threads so that my terminal can behave accordingly. So now if I send, this is able to print the message, and at the same time it's asking for my input. Now let's close everything, right? And let's remove this thread. Let's remove this thread context. Now I have removed this. Now let's clear everything up and make t join, my bad. Terminal, make. Okay, now let's start chat app 9099 port. Let's connect client 9099. 99. Okay, client 9099. Now C1 is connected, C2 is connected. Only one thread is running, which is main thread. That thread only is reading from the socket whatever is coming from the server. That thread only is writing to the server. So if I type here hello, nothing is happening. I have to make two threads, that's why, right? Let's remove everything, right? And let's close this complex stuff. Let's make everything clean. Now let me show you how to run debug mode. And the people who are new to our stuff, our channel, please subscribe and make sure you always use debugger perfectly. Now let's go to ChatRoom and let's put some debug point here. So let's put debug point in the main function only, right? When we create room, so we'll run our program, it will stop here. We can check whatever is defined till this point, like whatever the variables exist, argc, argv, till this point we will be able to see those, right? Let's see. And whenever we are accepting a connection, read, put a debug point there. And whenever we are reading, async read, put there debug point, right? That's how I'm able to debug. If you have, like, if you follow me on Twitter, you will know that this I made a tweet, right? Like, yeah, I'm not able to debug this. So yeah, whatever. So now because of this launch JSON file, you will be able to go here, gdb launch, right? And click on this point, right? Now your debugger is on, it stopped here. So now till this point, everything you can see whatever you have defined. Okay, even CPU registers you can see, right? CPU register. Okay, fine. Let's go. Room is created. Now till this point room should be created. You can go into the room, your queue is created. This room, whatever you created, has the queue, has the set with 0. Now if you want to run anything, let's suppose room, let's suppose you want to maybe ask message queue, because till this point I have the access to the room and it should have the access to the message queue. And size, users function running. Okay, room dot message queue. Okay, let me check. It is a private. Okay, private, I can't access. Join. Okay, oh, whatsoever. Let's suppose if room has some method and I want to test. I don't want to test that method in the code, but I want to test if that method is working. Till this point I can directly call that method in debugger mode, right? So let's skip to all the debug point. Now the accept connection is called, but accept connection, We are just registering this accept connection as a async method into our event loop. Till this point, no client has been connected to this server, right? So that's why this accept connection is registered in the IO context, but not it's not running. Now when I will run client app, now this client app will try to connect to server. Now it will come to join. Now everything will work as fine. Now async read is happening. Now async read is accept connection is again and async read is registered into our IO context. Now well, I'll return hello guys. Okay. First of all, I have to go back and I have to make sure this is happening in threads. Make okay, I have to recompile all of that because I changed my thread code. So now client will be able to okay, let's run everything fine. Now client 9099, it will come to join. It will register async read, but it will not do anything. Why? Because it's not have typed anything. Hello guys, enter. Now it is reading something. Let me, yeah, async read. Now it is happening. Where it is happening, see, the async read was registered when client connected, but it didn't run. Then we typed hello guys. Now the message came back. Now this callback function is registered, right? Is registered, and now this callback function is running. Our call stack is already empty. There is no call stack active. All functions are async read. Everything else has been run already. Like what I'm talking about is in main function there is sync code, which is not async, like making a room, everything is done. Now when accept is coming, now my call stack is empty. Now my callback of async read has callback. It can come into the queue and run. That is the power of async IO. So I hope everyone understood. Okay, I hope everyone understood today's project, right? It was awesome and I think you should share on Twitter यार. रीच नहीं आती है, कुछ नहीं करते हो तो, एंड 2 घंटे की वीडियो बनाने में आप कुछ नहीं वापस देते हो, बट ओके. So we'll come back soon with some updates around DBMS and special launch, not a course but something. This project you can extend, you can apply encryption, you can apply advanced encoding on headers, you can apply what else you can apply? You can apply analytics, how many clients are connecting, how many clients are leaving, you can make logs, right? How else you can extend the project? Just comment, right? Just comment, I'll approve if the extension of that project makes sense, right? We'll meet in next video. Till then, bye bye.